All right, the function f is given by f of x equals 4x cubed minus x to the fourth. On what intervals is the graph of f concave up? Okay, so where is it concave up? So this is all procedural. It's a fourth degree polynomial. It's a negative. So more than likely it's gonna do something like this, maybe, kind of like that. All right. So, anyways, but the procedure is that we gotta do what? F of x. Let's write down the function f of x is. Let me write it down correct, like the higher power first. F of x equals negative x to the fourth plus 4x to the third. So what's the procedure? What do we need to do? Go all the way to the second derivative so you can find the critical points for it, to find an inflection point maybe, yes. So let's take the derivative all the way to f prime of x is equal to, f prime of x is equal to negative 4x to the third plus 12x squared. F double prime of x equals negative 12x squared plus 24x. So we're trying to find the inflection points, if it has any inflection points. Factor out what? What do I factor out? Definitely what? 12x? Should I factor out the negative as well? Sometimes, let me factor out the negative as well. If we do send that, then what's going to be there? What's left over? X minus 2. Does it play a difference in if I do or don't factor it out a negative? See? If I didn't, I'm just gonna go ahead and factor out the negative. So x equal to 0, x equal to 0, and x equal to 2 are the points of inflection, possible points of inflection. So we do a number line here. That's the procedural way of doing it. So we do a number line, f double prime. Okay, so this is f double prime, and then we got here and here. Okay, so we got here. I'm gonna test 0 and 2, 0 and 2. Well. The second derivative is 0 at those points, so it is 0. F double prime is 0 at x equal to 0 at x equal to 2. So now we gotta figure out if there's any change of signs here. It has to have change of signs in order for it to have a point of inflection. So let's do f double prime of what? Negative 1. So if I test some number on the left of 0, f double prime of negative 1, and it's this function here. So right here, that's going to stay negative. It's going to be negative, isn't it? Test it. X is negative. That will make this negative, and it stay negative. So this is negative. We test. So this is going to be a negative answer. F double prime of 1 would be f double prime of 1. That would be positive. So this is positive. And then if we do, this is positive, and f double prime of 3, say 3. So 9, that's negative. That's negative. It's going to be negative. So there's a change of signs. See? Change of sign. Well, it's an inflection point here, and it is an inflection point here. So it's asking about Where's the graph of f concave up? So where is it at? Concave up? Where's huh? From 0 to 2, and we don't include 0 and we don't include 2, huh? That's what we said. So when it comes to inflection, when it comes to inflection points, we don't include the endpoints of it. We don't include. So from 0 to 2, the function f is concave. What intervals is the graph of f concave up? From 0 to 2, the graph is concave up. Yeah. Let's go to lesson 5.7. Go ahead and copy that graph down. This is the second derivative test. So we have this, like, say, third degree polynomial. We have a third degree polynomial. So we really need to understand what graph is given to correctly analyze it, no? So this is the f graph. So at x equal to a, what can we say about at x equal to a of f? Crystal, what can you say about x at x equal to a? What's going on with the graph? It has what? Huh? A relative max? Let's go with relative max. So the value of f prime at a equals, because you said that it has a relative max, then the value of f prime at a is equal to what, Crystal? What is the value of f prime at a? What's the value of f prime at a? You say, okay, anybody. What's the value of f prime at a?
0.
Because the slope is 0. So we really need to start really connecting derivatives and what they mean, and connect it to what a given graph is. That a given graph is the position graph, this one given. But f prime at a is the rate of change at a, which is the slope is equal to 0 at a. All right. Now, the next thing here, because the value of f double prime at a is blank, because the value of f double prime at a is, what's missing there? What do you think? Because the value of f double prime at a is what? What is f double prime at a? What is f double prime? See, this is the rate of change, at a, and this is what's going on with the rate of change. We're describing the rate of change at a. So what is it doing at a? What are the slopes along here? What are the slopes doing? What are the slopes doing? Then what? Well, the slopes are. Well, it's talking about concavity mostly. What? Is it concave up or concave down? It will f double prime at a is what? Concave up or concave down? It's concave down because what? F double prime at a is what? Is less than 0, no? Concave down means that f double prime is less than 0. It's negative, less than 0. So because the value of f double prime at a is less than 0, therefore, blank, is concave blank at x equal to a. Therefore what? Let's see. Therefore what? We said that it's concave down. So therefore something is concave down, because we already said if it's that's concave down. What is concave down? Therefore what is concave down? F of x. F of x. This function f is concave down. At x equal to a. It's like kind of like we could turn it the other way and say, because f of x is concave down at x equal to a, therefore the value of f double prime of a is less than 0. It's like you can switch it around too. What has a relative max at x equal to a? What has a relative max at x equal to a? F of x. F of x has a relative max at x equal to a. So we have to be very careful about, saying what it is, which function are you talking about? We'll do the same thing for the other one. The value of f prime at b is equal to, the value of f prime at b is equal to what? The value of f prime at b is equal to what? Anybody? 0. The value of f prime at b is equal to 0 because the value of f double prime of b is what? Well, then we're going to continue on. Because the value of f double prime of b is what? What's going on there? It's greater than 0, no? Because it's concave up, isn't it, there? It's greater than 0 because the value of f double prime at b is positive, or in other words, greater than 0. Therefore, f is concave up at x equal to b. And because these two things are true, then we can say that f has a relative min at x equal to b. So it has two parts. The second derivative test has two parts. First, you have to say something like this, that the value of f prime of b is equal to 0. Then you can say that also because the value of f double prime is greater than 0, then you can say that it has a relative min or max. In this one, it was min. Same thing with the top one. You have to say that the value of f prime at a is 0. And also because the value of f double prime is less than 0, f of x has a relative max at x equal to a. Okay. Let's do some problems then now dealing with this. Okay, here, problem 1. Use the second derivative test. Use the second derivative test to find the relative extrema of f of x equal to that. Which one are you missing? The 5, 6? Is it? I gave 5, 5 already?
Yeah, 5.
It's just 5, 5 and then 5, 7 for today. Okay, so use the second derivative test to find the relative extrema of f of x equal to that. So what is the procedure? What is the procedure is we have to take the derivative to find the possible relative extremum or relative max, relative min. So step one is take the derivative, f prime of x equal 4x cubed minus 4x. Set it equal to 0. See, we're going to set the first derivative to find where the slope is equal to 0. 4x cubed minus 4x. Factor out 4x. X squared. Minus 1. So 4x, what is this? The difference of squares. So what is it? What's the answer here? What's the answer for x squared minus 1? X plus 1, x minus 1. So x equal to 0. X equal to 0 is a possible extrema. X equal to negative 1 is a possible extrema. X equal 1. X equal to 1 is a possible extrema. So the second derivative test says that you want to figure out the concavity at these points, no? So we're going to test if it's concave. And so we're going to go to the second derivative. Let's go to the second derivative. And then plug and test each point at the second derivative. The second derivative is going to be 12x squared minus 4. Okay? So there's the second derivative. And we're just going to test each one of these for concavity. So f double prime at 0. F double prime at 0. What's the answer? We care about the sign only. Is it positive or is it negative? It's negative, no? So here we already got one. This is concave what? Concave down. The f function is concave down, so it has a relative max here. F double prime at negative 1 is used. So at negative 1 it would be what? Negative 1 would be we're doing double prime. What is that? Is that positive? Yes or no? We're plugging into f double prime here, no? In negative 1, I'm doing negative 1. That's positive, yes? Yes? And what does this mean? It means that it's concave up, no? Yeah? So this has to be a what? And this is f. No? That's a relative min. And f double prime of what? Of 1 is going to be what? F double prime of 1? That's going to be what? Also, that's positive. That's positive. That's positive. And that's going to be a concave up, no? So F. So that's a relative min. Okay, so how do we summarize this that we got? How do we summarize? Let me give you a sentence frame. It's a little bit different than what we just did, no? Let me give us, how do you summarize this? Okay, here's the summary. Here, a sentence frame, if you want to use this sentence frame. F of x has a relative min at, this is positive, concave up. Yep, concave up. So, at negative 1, f of x has a relative min at x equals negative 1 because f prime at negative 1 is 0 and f double prime is positive, greater than 0. I could have just used it for the other one that was the relative min as well. At x equal to 0, f of x, we're going to be talking about f has a relative max at x equal to 0 because f prime of x is 0 and f double prime is less than 0. We could have just done it the same. I could have just said f of x has a relative min at x equal to -1 and at x equal to 1 because, but I guess you have to separate them for the reasons why. This is fine. This is very thorough in its explanation. Let's go to number 2. All right, number 2. So number 2 says, find the critical points, use the second derivative to find the relative min, relative max, and draw a sketch of the graph. So let f of x equal this third degree polynomial. So the steps are that you take the first derivative, set it equal to 0 to find possible candidates for relative max mins, and then test each one of those critical points for by taking a second derivative, plugging it into the second derivative, and see if it has a positive or a negative, or it comes out to 0. F prime of x. F prime of x is x squared plus 8x plus 7. Set it equal to 0. Find the factors x and x. What is that? What are the numbers? 7 and 1. Meaning that the candidates would be x equal. Let's do -1 first on the left, and then x, no. -7 first. And -1. So x equal -7 and x equal -1. Take the second derivative, f double prime of x, and then this is going to be 2x plus 8. So f double prime of -7 is equal to what? F double prime of -7. That is what? Negative? That is negative? It's a negative, so it is concave. So then at that point, what we're getting is that at x equal to 7, -7, it is concave what? It's concave what? So the function f is concave down, so it is a relative max, no? And if we do what, f double prime of what, of -1, that would be what? Positive, no? That would be positive, meaning it's concave up, no? So then this has a relative min. F relative min. Draw a sketch of a graph. Well, let's say this is F. So it does have a relative min or relative max at x equal -7. -1, -2, -3, -4, -5, -6, -7. 1, 2, 3, 4, 5, 6, 7. So at x equal -7, it has a relative max at x equal -7. So you can go ahead and plug in -7 into f to find what the max the actual max of f is. Then you can plug in x equal -1 in here to find the actual relative max. Min. I'm not doing that. Okay, so we could just f has a local maximum at x equal -7. That's what it looks like. So if you really wanted to find the actual maximum value, you plug in x equals -7 into f, and that would have gave you this number here. And if you plug in min x equal -1, that would have gave you this number by plugging it into f. Where's the inflection point at? Where's the inflection point at x equal -4? It is concave down here, and it's concave up right there. What can you say about f here? F double prime here? Every single one of these points is going to be what? F double prime is what? Less than 0, and here what? F double prime is what? Greater than 0. And we're done.